Welcome to Algebra 2, 1.4 and 1.5 lesson over formulas, equations, and problem solving. So today there's actually a couple of objectives. You will rewrite and evaluate formulas and equations, and you will solve problems using verbal models. And we practiced that a little bit last time, so we will continue to do that. So what is a formula? It's an equation that relates two or more quantities usually represented by variables. So one that you're familiar with is that perimeter equals 2 times length plus 2 times width. To solve for a variable means to rewrite an equation as an equivalent equation in which the variable is on one side by itself and does not appear on the other side. So let's look at an example. All right, we're going to solve the formula C equals 2 pi r. Y'all are used to the circumference formula. We're going to solve it for r, and then we're going to find the radius of a circle with circumference of 44 inches. So there's two parts to our answer. One is a formula r equals, and then the other one we're actually going to plug in a value for a circumference and get a specific radius. Okay, so we're going to solve for r. We're going to write down the formula as it was given to us, C equals 2 times pi times r. So we're going to undo everything being done to r. So we're going to divide both sides by 2 pi. So C over 2 pi equals r. So that is one part of our solution. The second part of our solution is going to be when we substitute the given value into the rewritten formula. So we're going to substitute 44 for C and then simplify. So we get that r is going to equal 44 over 2 pi, which if you use your calculator, you'll see approximates to be 7. So the radius of the circle is about 7 inches. Now, really, even though this is saying that's the final answer, that's true. But when I'm checking things like this, I'm going to want to see the formula solved for r. Okay, so you need to make sure you've got C over 2 pi equals r somewhere. Now, we're going to solve 9x minus 4y equals 7 for y, and then we're going to find the value of y when x equals negative 5. So again, you're going to have two parts to your answer. Okay, to solve the equation for y, we're going to write the original equation, and then we're going to isolate first 4y by itself on one side of the equation, or negative 4y, and then we're going to actually solve for y. So we subtract 9x from both sides to get that negative 4y by itself, and it's going to equal 7 minus 9x, and then we're going to divide both sides by negative 4. And so we get y equals, we're going to do our division term by term. 7 divided by negative 4 gives us negative 7/4. And then negative 9 divided by negative 4 gives us plus 9/4, and then the x. And so that is one of our answers right there. The other answer is going to come from substituting the given value into the rewritten equation. So we're going to substitute negative 5 for x. So where we had x before, now we have negative 5. So 9 times negative 5 gives us negative 45/4 plus negative 7/4. Let's see, that's going to give us negative 52/4, which reduces down to negative 13. All right, problem solving. It is helpful when solving real-life problems to write an equation in words before you write it in mathematical symbols. This word equation is called a verbal model. To write your verbal or algebraic model, as you might use problem-solving strategies such as using a formula, looking for a pattern, or drawing a diagram. Okay, let's use a formula. And the Acela train travels between Boston and Washington, a distance of 457 miles. The trip takes 6.5 hours. What is the average speed? Okay, so what we're going to do is we're going to use the formula for distance traveled as a verbal model. So distance is equal to rate times time. And so in this case, our distance is in miles, our rate is in miles per hour, the speed, and then time is the number of hours it takes. So 457 equals r, that average speed we're interested in, times 6.5. We're going to solve for r. So if 457 equals 6.5 times r, r is being multiplied by something, so we need to divide by it. So we're going to divide each side by 6.5. So 70.3 approximately, rounded to the nearest tenth, is equal to r. So the average speed of the train is about 70.3 miles per hour. Okay, to check this, you can use unit analysis to do the check. 457 miles is approximately 70.3 miles per 1 hour times 6.5 hours. The hours cancel out. 70.3 times 6.5 gives us approximately 457, so we're good. Let's look at example 4. Okay, so here is a picture of somebody paramotoring. Okay, a paramotor is a parachute propelled by a fan-like motor. Pretty cool. The table shows the height h of a paramotorist t minutes after beginning a descent. Find the height of the paramotorist after 7 minutes. Okay, so let's look at the table and talk about what it tells us. All right, the initial time is time 0. Okay, that's right when the paramotorist starts. Okay, and so the initial height is 2,000 feet. After 1 minute, the paramotorist is at 1,750 feet. After 2 minutes, the paramotorist is at 1,500 feet. So as time goes by, the paramotorist is descending to the ground. Okay? So let's look at the solution. The height decreases by 250 feet per minute, right? From 2,000 to 1,750, that's a subtraction of 250 feet. And then it's going to go down another 250 feet to 1,500, and then again and again. So we can assume that pattern is going to continue. You can use this pattern to write a verbal model for the height. The height is going to equal the initial height minus the rate of descent, the number of feet per minute of altitude that the paramotorist is losing, because it's wanting to head to the ground, and times time, the amount of time that the paramotorist has actually been descending. So algebraically, h equals 2,000, that initial height when time was 0, minus 250, because that's the rate of descent, times time. So the equation is h equals 2,000 minus 250t. So that is the model. Okay, that's the model for any point in time, t. So after 7 minutes, h is equal to 2,000 minus 250 times 7 is equal to 250 feet. So the paramotorist has 1 more minute before he or she is going to descend. Let's look at one more word problem about banners. And on this one, drawing a diagram is going to be helpful. You are hanging 4 championship banners on a wall in your school's gym. The banners are 8 feet wide. The wall is 62 feet long. There should be an equal amount of space between the ends of the wall and the banners, and between each pair of banners. That way it looks nice. How far apart should the banners be placed? All right, let's begin by drawing and labeling a diagram as shown. All right, so we know across the wall there's 62 feet. Okay, that's what this is telling me. Okay, there's 62 feet. So I need a space that's x. We don't know how big the spaces should be, but we're going to have a space because between the wall and the banners there should be a space. And then we'll have our first banner, which we do know is 8 feet long. And then we have another x feet of space, and then we have our second banner, which is 8 feet long. And then we have another x feet of space. Our third banner, 8 feet long, space of x feet. Fourth banner and last banner, which is 8 feet long, and then we need that same amount x feet of space there till we get to the second wall. So we're going to have x plus 8 plus x plus 8 plus x plus 8 plus x plus 8 plus x equals 62. Okay, that's our equation. So you can see it's all written out there. So what we want to do is we want to combine like terms. So if you count your x's, you've got, let's see, 1, 2, 3, 4, 5 x's. And then 8 plus 8 plus 8 plus 8 is 32. So 5x plus 32 equals 62. So we're going to subtract 32 from each side. 5x equals 60. Divide by 5, and we get x equals 6. So each of those little banners needs to be placed 6 feet apart. Okay, guys. That is it for examples. You are ready to try the problems to try on your own. Now, if you get stuck on one of those, make sure you go back and either rewatch the video, come talk to me, go in for some peer tutoring, because remember, you will not get full credit for your notes if you have not tried, and I mean really done a good job on those problems to try on your own. Okay, so make sure that you do that. All right, guys, I look forward to seeing you in class or earlier if you need to come by and get some help. Okay, have a good day. I will see you soon.